When VT graph is given, how to calculate average acceleration and instantaneous acceleration? VT graph, let me take again a rough graph. He asks you to calculate average acceleration between times t1 and t2. So you identify those t1 and t2 here. Corresponding velocity values you read from velocity axis, that is v2. So this is t1, this is t2. So this will be t2 minus t1. Also this will be t2 minus t1. Now this will be v1 and this will be v2. So this will be v2 minus v1. So this is also equal to v2 minus v1. So if you do v2 minus v1 by t2 minus t1, that is equal to average acceleration from definition, or this is also equal to slope of line joining these 2 points. Suppose if you can read v1 v2 values, so v2 by v1, v2 minus v1 by t2 minus t1 gives you average velocity. Otherwise, if you can read this theta value, angle made by this straight line with the time axis, so tan of this angle also gives you slope of straight line, or this is equal to v2 minus v1 by t2 minus t1. It gives you average acceleration. So slope of line joining t1 v1 comma t2 v2 from VT graph. From VT graph, this is equal to average acceleration. And how to calculate instantaneous acceleration? Definitely is going to give you the time at which you have to calculate instantaneous acceleration from VT graph. Suppose if you take any arbitrary point, let me take this is time t. At this time he asked us to calculate instantaneous acceleration. Then what do? You draw a tangent to this graph at this point, and the slope of this tangent drawn to the VT graph gives you dv by dt, that is equal to instantaneous acceleration. And the slope of this straight line also we can calculate if theta is known, that is tan theta. Otherwise you can take any 2 points. This is t1, this is v1, this is t2, this is v2. So v2 minus v1 by t2 minus t1 also gives you slope of this straight line, but the straight line is tangent to VT graph. So you will be getting slope of tangent drawn to VT graph at particular point. So by definition that is equal to instantaneous acceleration at that point.